frozen landscape as snow begins to fall heavily on the Eurasian steppe. Temperatures have dropped to -40 degrees Fahrenheit, and for the next 6 months, this land will be locked in winter's grip. A modern human would last perhaps hours in these conditions without proper shelter and heating. Yet 30,000 years ago, entire families not only survived, but thrived through winters like this, raising children and creating some of humanity's most sophisticated art. They had no permanent walls, no central heating, no insulated buildings. So how did our Paleolithic ancestors survive the harshest winters in human history? The popular image of early humans during ice ages usually involves huddling around fires in the mouths of caves, but this picture is woefully incomplete. Archaeological evidence reveals that our ancestors developed winter survival technologies so effective that they enabled human expansion into the most challenging environments on Earth. From the Mammoth bone houses of Ukraine to the snow caves of Siberia, Paleolithic peoples created winter shelters that would impress modern Arctic engineers. The story begins with a simple but revolutionary realization. When nature tries to kill you, you make nature work for you instead. This principle guided every aspect of Paleolithic winter shelter design, from material selection to construction techniques to heating systems. Rather than fighting against snow, wind and cold, our ancestors learned to harness these forces for protection. Archaeological evidence for sophisticated winter shelters comes from sites across the northern regions, where early humans pushed the boundaries of habitability. At Kostroma in Russia, dating to 800,000 years ago, researchers discovered remains of what may be humanity's first engineered cold weather housing. These early Arctic pioneers had excavated circular depressions up to 8 feet deep and 12 feet across, creating the foundations for semi-subterranean winter homes. The engineering principles behind these underground shelters were remarkably sophisticated. By digging below the frost line, early humans accessed the Earth's natural insulation properties. At depths of 6 to 8 feet, soil temperatures remain relatively stable year-round, typically 20 to 30 degrees warmer than surface air during winter. This wasn't accidental. Tool marks and soil analysis show these depths were deliberately chosen for maximum thermal efficiency. But the real breakthrough came with the development of composite insulation systems. At Dolni Vestonice in the Czech Republic, dating to 26,000 years ago, archaeologists uncovered evidence of winter shelters that used layered insulation techniques not seen again until modern times. The walls of these structures incorporated multiple material layers, each serving a specific thermal function. The innermost layer consisted of carefully prepared animal hides, with the fur side facing inward to trap warm air against occupants' bodies. Outside this, a layer of dried grass and moss provided additional insulation and helped wick moisture away from the interior. The outermost layer used woven mats made from reeds and bark, creating a wind-resistant barrier that also allowed moisture to escape, preventing condensation that could freeze and compromise the shelter's integrity. The most famous examples of Paleolithic winter architecture come from the Mammoth bone houses of Ukraine and Russia. At sites like Mazhirik and Kostenki, dating between 25,000 and 15,000 years ago, researchers discovered the remains of structures that represent some of the most sophisticated prehistoric architecture ever found. These weren't simple huts, but engineered buildings designed specifically for extreme cold survival. The Mammoth bone houses began with carefully planned foundations. Builders excavated circular or oval depressions approximately 12 to 16 feet in diameter, designed to accommodate extended families of 8 to 12 individuals. The excavated earth was piled around the perimeter to create berms that provided additional wind protection and thermal mass. The framework of these structures used the massive bones of woolly mammoths, animals that had evolved their own sophisticated cold adaptations. Mammoth skulls, some weighing over 200 pounds, were used as foundation blocks. Curved tusks and long bones created the dome-shaped framework, while hundreds of smaller bones filled gaps and provided structural support. Radiocarbon dating shows that many of these bones came from long-dead mammoths, indicating that builders were systematically collecting materials from boneyards rather than hunting specifically for construction materials. The covering system for mammoth bone houses revealed extraordinary innovation in textile technology. Analysis of preserved organic materials shows that builders created composite wall systems using multiple types of animal hides. Thick mammoth hides form the structural outer layer, sewn together with sinew thread using bone needles. Inside this, layers of smaller animal pelts from wolves, foxes and Arctic hares provided additional insulation. The entire covering system was anchored to the bone framework using a complex system of hide ropes and bone toggles. Heating these large winter shelters required sophisticated fire management techniques. At most mammoth bone house sites, archaeologists have found evidence of multiple hearth systems designed to maximize heat distribution while minimizing fuel consumption. Central hearths provided the primary heat source, while smaller heating stations around the perimeter created warm zones for specific activities like food preparation and tool making. The fuel management systems were equally impressive. In treeless steppe environments, Paleolithic peoples couldn't rely on wood for heating. Instead, they developed techniques for using mammoth dung, dried grasses and bone as fuel. Chemical analysis of hearth residues shows that these alternative fuels were processed and prepared to maximize their burn efficiency and heat output. But perhaps the most ingenious aspect of Paleolithic winter shelters was their ventilation systems. Modern Arctic engineers understand that proper ventilation is crucial for cold weather structures. Without it, moisture from breathing and cooking creates condensation that can freeze and make shelters uninhabitable. Archaeological evidence shows that Paleolithic builders solved this problem with remarkable sophistication. At sites like Kostroma, researchers found evidence of carefully designed airflow systems. Small openings near ground level allowed fresh air to enter the shelter, while larger openings near the top allowed warm, moisture-laden air to escape. The positioning of these openings created natural convection currents that maintained air quality while preserving heat. Some sites even show evidence of adjustable ventilation systems, with bone and hide flaps that could be opened or closed, depending on weather conditions. The social organisation within winter shelters reveals fascinating insights into Paleolithic family life. Archaeological evidence suggests that these structures were designed for extended family groups, with specialised areas for different activities and age groups. Sleeping areas were typically arranged around the central hearth, with the warmest spots reserved for infants and elderly family members. Tool-making areas were positioned near secondary hearths where good light and heat were available for detailed work. Food storage within winter shelters was another crucial innovation. In permafrost regions, Paleolithic peoples learned to use natural freezing as a preservation method. At many sites, archaeologists have found evidence of underground storage chambers connected to winter shelters by short tunnels. These natural refrigerators kept meat fresh throughout the winter, while remaining accessible even during severe storms. The construction timeline for these winter shelters reveals remarkable planning abilities. Experimental archaeology suggests that building a mammoth bone house required 2 to 3 weeks of intensive work by a group of 8 to 10 adults. This means construction had to begin well before winter weather made outdoor work impossible. Analysis of tool wear patterns and seasonal indicators suggests that most winter shelters were built during late summer and early autumn, demonstrating sophisticated seasonal planning. Maintenance of winter shelters was an ongoing concern throughout the cold season. Archaeological evidence shows that occupants regularly repaired and upgraded their structures as winter progressed. Broken bones were replaced, damaged hide coverings were patched, and insulation materials were refreshed. This wasn't simply reactive maintenance, but proactive engineering that improved shelter performance over time. The psychological aspects of winter shelter design were also carefully considered. Living in enclosed spaces for months at a time could lead to serious mental health issues, something that modern Arctic researchers know well. Paleolithic builders addressed this by incorporating features that provided psychological comfort and social functionality. Many winter shelters included specialized areas for artistic activities. The famous Venus figurines found at many Paleolithic sites were often discovered in winter shelter contexts, suggesting that long winter months were times for creative expression. Cave art, while often associated with caves, was also created within winter shelters using portable art objects and decorated tools. The end of winter required its own specialized techniques. Archaeological evidence suggests that many winter shelters were deliberately dismantled at the end of cold seasons, with valuable materials cached for reuse the following year. Bone frameworks were often left in place, covered with earth and stones to prevent scavenging, while portable materials like hides and tools were packed for seasonal migration. The thermal efficiency of Paleolithic winter shelters was remarkable by any standard. Experimental reconstructions have shown that properly built mammoth bone houses could maintain interior temperatures 40 to 50 degrees warmer than outside air, using only modest fires. Modern Arctic shelters, with access to industrial insulation and heating equipment, often perform no better than these Stone Age structures. The techniques developed for winter survival had profound impacts on human evolution and expansion. The ability to survive harsh winters allowed early humans to colonize vast regions of northern Eurasia that would otherwise have been uninhabitable. This expansion brought access to new resources and hunting grounds, supporting larger populations and accelerating cultural development. Many of the innovations developed for winter shelter construction found applications in other areas of Paleolithic technology. Composite material techniques used in winter shelters were adapted for clothing, tool handles, and hunting equipment. Insulation principles were applied to food storage and protective clothing. The engineering mindset required for winter shelter construction likely contributed to the technological explosion of the Upper Paleolithic period. The knowledge required to build effective winter shelters was extensive and had to be transmitted across generations with perfect accuracy. Mistakes could be fatal. This need for precise knowledge transmission may have contributed to the development of complex teaching methods and cultural practices that ensured survival information was preserved and passed down. Regional variations in winter shelter design reflect local adaptations to specific environmental challenges. Arctic coastal peoples developed techniques for building on permafrost, while continental steppe dwellers perfected methods for dealing with extreme wind exposure. Mountain peoples created avalanche-resistant designs, while forest edge inhabitants learned to integrate natural windbreaks into their shelter systems. The abandonment of these sophisticated winter shelter technologies following the end of the ice ages represents one of the great technological losses in human history. As climates warmed and forests expanded, the need for extreme cold weather shelters diminished. The knowledge was gradually lost, surviving only in a few Arctic regions where environmental conditions remained challenging. Modern Arctic engineers studying Paleolithic winter shelters have gained new insights into cold weather construction techniques. Military Arctic training programs now teach shelter building methods directly derived from archaeological reconstructions of Paleolithic designs. Disaster relief organizations have adapted these ancient techniques for emergency shelter construction in extreme environments. The story of Paleolithic winter survival is ultimately a testament to human adaptability and engineering innovation. Faced with environmental conditions that should have been impossible to survive, our ancestors didn't retreat to warmer climates. Instead, they developed technologies that allowed them to thrive in the harshest environments on Earth. When we consider the sophisticated thermal engineering, the complex material processing, the precise construction techniques, and the detailed environmental knowledge required to build these winter shelters, we see not primitive cave dwellers, but accomplished Arctic engineers. Their innovations laid the groundwork for all subsequent cold weather technologies and demonstrated the fundamental human capacity to overcome environmental challenges through ingenuity and cooperation. The next time you adjust your thermostat or check your home's insulation, remember that the principles you're relying on were first developed by families living through Ice Age winters with nothing but stone tools and natural materials. Their legacy lives on every time we create warmth and safety in the face of winter's challenge.